Hello everyone, this is Ashutosh Ranjan. I am third year undergraduate from IT Kanpur. I am doing a machine learning project, handwritten digits recognition from Skyfi Labs. So, this is the code for the project. I have imported NumPy and Matplotlib libraries. I have also imported Keras from TensorFlow to implement neural network. It works as a front end with TensorFlow as the backend. Again, I have imported regularizers from Keras library to regularize our model to avoid overfitting. Here I have loaded the MNIST dataset from Keras and stored it in data. We can see that the data is structured in two rows and two columns. First row contains the training images and second row consists of testing images. Moreover, the second column contains the labels for training and testing images respectively. We can see it here. Now I unpack the data into training images, training labels, testing images, and testing labels. Images are stored as NumPy arrays, which can be seen below. We can see that the number of training examples are 60,000, where the shape of each example is 28 cross 28. Similarly, the number of testing example is 10,000 and shape of each example is also 28 cross 28. Our first training label is 5 and testing label is 7. We can see that both test and train labels consist of numbers 0 to 9 uniquely. As an example, I am printing the first training label 5 by cropping 5 rows and 5 columns respectively. This image roughly looks like 5. Now for the visualization of data, I am using plt.subplot to visualize first 10 training data. MNIST dataset is already pre-processed, but we need to do scaling. So before scaling, we can see that the pixel values varies from 0 to 255. But after scaling, that is by dividing it by 255, we get the pixel values from 0 to 1. Now let us set up our layers of artificial neural network. In Keras, the neural network model is the sequential model, which means that the model consists of layered objects. So the first layer is the input layer with input shape 28 cross 28. After that, there are two hidden layers with 100 neurons each with regularization parameters 0.0001 and using sigmoid as their activation function. And the final layer consists of 10 classes of neural network, that is from 0 to 9, which is also the output layer. Now I am structuring the weights of the first hidden layer by using model.layers and then using getWeights, which return two NumPy arrays, one for the weights and the other for biases. We can see that shape of weights is 784 cross 100 and shape of biases is 100 for each neuron. Similarly, I have structured the weights for the second hidden layer and the output layer correspondingly. After that, I compiled the model with learning rate of zero point 0.2, TK of 10 raised to power minus 6 and momentum of zero point 0.5. I have used SDD, that is stochastic gradient descent, as optimizer, sparse categorical cross entropy as loss, and accuracy as metrics to compile the model. Then finally, I trained the model using model.fit, having the number of epochs as 15, batch size as 100, and 20% data for the validation. Model.fit returns a dictionary containing validation loss and training loss, which is stored in history. Now, for the purpose of visualization, uh, how the training and validation loss varies with the number of epochs, I have used this code. We can see that as the number of epochs increases, both training error and the validation error reduces. And finally, the difference between the training error and validation error also becomes small. I have also computed the accuracy of the model over the testing data using model.evaluate, which comes out to be 97%. I am also predicting the labels for the testing images and storing them in predictions for future reference. I have defined this function in order to display the image along with the confidence level, which takes three things as parameters: images, its correct level, and its prediction. So, if the predicted level is not equal to the correct level, the background color of the title becomes red, otherwise, it is green, with white as the color of text of the title. We can also visualize the first 10 samples of the testing dataset using the function that we defined just above. I am also calculating the number of incorrectly classified image from the testing dataset and also visualizing the first 10 of them. In our case, the number of incorrectly classified image comes out to be 304, which is not very high considering that our model is not prone to overfitting. So thank you.